we go over argument and modulus of a complex number. Well, when you're finding the modulus of a complex number, all you are taking is the distance of that complex number. So consider this: if you've been given a complex number z which is equal to a plus ib, the meaning of this is going to be, it is going to have, this is the real part when it comes to a complex number, this is the imaginary part. So the imaginary part contains an I, so the value here is b. Of course, on this portion we don't show the I. Immediately you see something on the imaginary part, then it contains an I automatically, and then the real part is a. So this is the complex number which we have with these components: the x component, which is the real component, and then the y component, which is b, the imaginary component. Now what we want to find, the modulus, we want to find the distance here. So look at this: we have got this as the y and then this as the x. Now we've got the real part, x is representing the real part, and then y is representing the imaginary part. You just get a part without the I. Okay, you don't include the I when you are taking the value. So that is the form. Now how do we find the modulus? Let's say we've got a complex number z which is equal to 4 minus 3i. So the modulus of this function, or I mean of this complex number, is simply the absolute value or the distance of this complex number. Now what we do is we get the x value, we square it, plus the y value, we square it, and then we square root. It's just like taking, what we are just applying is the Pythagoras theorem, and this is the hypotenuse, the modulus. Okay, 4 squared is 16, 3 squared is 9, 16 plus 9 is a 25, the root of 25 is a 5. So that is the modulus of that complex number. Now say you've got a complex number z which is equal to negative 4i. Now if you've got a complex number like this, that means it doesn't have any real part. It is along the imaginary axis. It's going to be somewhere there if that is negative 4. It doesn't have a real part. And so same, when you want to find its modulus, you get the x component. Now the x component is 0, so that will be 0 squared. Get the y component, which is negative 4. You just get a number in front of I and square it, and then take the square root of that. Well, that is going to give us 0 squared, which is a 0. Negative 4 squared is a 16. The square root of 16 is a 4. So that is the modulus of that complex number. What of the complex number z, which is equal to 4? Okay, let's say negative 4. What will be the absolute value or the modulus for this complex number? Now what this means is this complex number just has the real part. It doesn't have any imaginary part. Well, how is it a complex number if there is no I? All real numbers are complex numbers, so they are a subset. So this is also a complex number, but it doesn't have any imaginary part. So the absolute value then is going to be the absolute value of the real part. So the real part, you square it. The imaginary part we don't have. So negative 4 squared is 16. The root of 16 is a positive 4. So that is the absolute value for that then. Consider a complex number z which is equal to I. What would be its absolute value? Or what would it be? What would its modulus be? So that will give us x. We can see that there is no real part. The real part is 0. The imaginary part, the number in front of I, is a 1 there. So that will be 1 squared, and then square root that. So that is going to give us the square root of 0 squared plus 1 squared is a 1. We'll just have a 1 inside there. The square root of a 1 is a 1. So after looking at modulus, we need to understand also argument. Now when you've been given a complex number like that, we said we can put this on an Argand diagram. So this is an Argand diagram where this is B, this is A. This is the imaginary part. This is the real part. So this is a complex number here. Now the angle that it makes with the x-axis is what is called the argument, that theta. That is called the argument. Now when you are finding argument, the angle is supposed to lie between 180 degrees, negative 180 degrees, and also positive 180 degrees. We are more interested in finding the angles between these two ranges, so don't want to exceed this. So if you find an angle which is above this, you have to convert it to be between these two limits when you want to give the argument. Okay, so let's consider an example. So I've got a complex number z which is equal to 3 plus 4i. So what would be the argument for this angle? Well, we know that negative 180 is the same as negative pi. So if we are dealing with radians, our answer is supposed to be between negative pi and positive pi. Now pi is approximately 2.1, let's see, 22 over 7. That is 3.14. So it should be between negative 3.142 and positive 3.142 when we are dealing with radians. So that is the value that we're supposed to give. Now if you consider this complex number, both x and y are positive. That means this complex number is in the first quadrant. So this complex number is going to be there where x is positive 3 and then y is positive 4. Of course, this is representing the imaginary, and then this is representing the real root or the real part. So to find its argument is found by taking the tan inverse of y over x. So that will give us tan inverse. The y value here is 4, x value is the 3. Now tan inverse of 4 over 3, okay, that value is about 0.927 when you are working in radians. So we can say that 0.9 is between negative 0.34 and positive 3.14. Negative 3.14 and positive 3.14. So that is the argument for this. This is the angle theta. That is the argument. Now, say you've been given a complex number z which is equal to, can we take 4 minus 2i? So we've been given such a complex number. So by looking at this, in which quadrant is it going to be? So x is positive, y is negative. So it's going to be in this quadrant. That is where we see that complex number. And so the angle that we are going to find is this one, theta. Okay. So this should tell us that, okay, let's go and find theta is going to be tan inverse of y over x. So that is going to give us tan inverse. Our y value is negative 2. The x value is 4. This is the same as tan inverse of what? Negative 1 over 2, if we work out what is inside there. So let's punch on the calculator, we see what we are getting. The absolute, the tan, taking a tan inverse of negative 1 over 2, which is the same as negative 0.5. In radians, the answer is going to be negative 0.464 radians. So this is the angle here, negative 0.464. So that is the value then. That is the argument. So when you've been given a complex number on an Gantt diagram, if it is here, you are going to take that. If the complex number is here, what you want to take is this one. When the complex number comes to this quadrant, what you want to take is this. If it goes there, what you are going to take is this, instead of taking it from the positive x-axis like this up to here, that number is going to exceed 180 degrees. So that is why we take this portion to give the argument. Well, let's look at an example. We see says z is equal to negative 3, let me say negative 4 minus 4i. What would be the argument for this complex number? Now, just by looking at it, x and y are both negatives, so it's going to be in this quadrant. So the angle that you find by taking the tan inverse would be that. So this will give us theta being equal to tan inverse of y over x. So this will give us tan inverse. Our y is negative 4. Our x is also negative 4. So this gives us tan inverse of a positive 1. Now, tan inverse of a 1, this is a special angle, is 45 degrees. Well, the 45 we have found is here. Though this angle is looking positive, it starts from there, it goes like that. So, for angles which are down the x-axis, you want to give it starting from the positive x-axis. Now, if we went like this, we are going to exceed 180 degrees. So, we are going to take this part like that. Now, if we take that part, notice that angles are measured going in the anti-clockwise direction, but this one is going in the clockwise direction, and so it's going to be a negative angle. And how do we find that? So that is found by removing 180 from this value that we have found. So 45 minus 180 degrees, that is a negative 135 degrees. So this is the argument. So this is 135 degrees, in other words. The reason as to why it is negative is because we are going in there and the clockwise direction. So basically that is how we give the argument, and that is how we find the modulus of a complex number.